Okay, so we're looking at section 3.2. This is part 2 of the notes. We're going down here to where it says day 2, and your problem says to solve x squared plus 9 equals 0. I want you to think about this logically for a minute. Is there a number that you can square, add 9 to it, and get 0? No, there's not. What would you say, 3? But okay. Yeah, that's a common thing that people think. And I want to show you on the calculator too. Turn on your calculator. Clear it all out. Go to y equals. If you have anything in there, clear it. Make sure all your plots are off, or else you're going to get an error message. These should all be off, just a graph. Put in x squared plus 9 and hit graph, or do a zoom 6 actually to give us same screen. Zoom 6. There's x squared plus 9. Why does it look that way? It's a parabola that has been moved how far? 9 up, right? I'm going to extend my window, my y max. I'm going to make it 20 so I can see that better. There's the function. I want to know, where does this function y equals 0? Y equals 0. Are these ever going to intersect? So there is no real solution to this. These will never intersect. But we can still find an answer, because mathematicians decided that every equation should have some type of solution. Even if it's not a real solution, it's going to have a solution. So if you're asked to solve this, we're going to have to subtract 9 from both sides. And we get x squared equals negative 9. We take the square root. What do we have to put anytime we have an equation and we take a square root? Plus or minus. And how do we write the square root of negative 9? 3i. So this equation has no real solutions, but it does have two imaginary solutions. One is positive 3i, one is negative 3i. All right, visualize x squared plus 20 equals 0. Visualize the graph. Is this function ever going to equal 0? No, so that means we're going to have what kind of values in our solution? Imaginary, right. So solving this, I'm going to have x squared equals, take the 20 over, negative 20. Take the square root of both sides, x equals plus or minus. Anybody know how that would simplify? 2i radical 5, very good. That's because 20 is 4 times 5, square root of 4 is 2. Anytime there's a negative under the radical, the I comes out. All right. Here's where we pick up the notes. Scroll down until you get to here for day 2. Okay, this equation, let's go ahead and solve it. I can either take the 5x squared over here, or I can take the 25 over here. I think I'm going to take the 25 over here. And it's going to become negative. Now I'm going to divide by 5. And I have negative 5 equals x squared. Now we're going to take the square roots, and I'm just going to go ahead and use the symmetric property and put x over here and put my plus or minus. And how do I write this? I radical 5, yeah. Easy enough. Okay, go ahead and try this one on your own. I'm not going to talk you through it. If you get stuck, you can look up here. Get it right?
Yeah.
All right. Let's go on over to number 5. This problem at the beginning looks very difficult, but we are always allowed to multiply or divide any equation by any number we want to. Not variables. We can't multiply or divide by variables, but we can by constants. So what would be the constant that I could multiply this by to get rid of the fractions? 15. So I have to multiply every term by 15. Negative 1/3 times 15 is going to be 15 times 1 divided by 3 is negative 5x squared. This is over 1. 15 times 1 divided by 5 is 3. Now, I can do 15 times 4 divided by 3, but I can also do 15 divided by 3 and then times 4. Let's do it that way. What's 15 divided by 3 times 4? 20. Okay, so now I'm going to go ahead. I'm going to take my x squared to the left. Okay, now I want to help you here at the end with this one. So right now I've got x squared equals negative. This negative can go anywhere, guys. Even though I divided by negative 25, I can put the negative in the bottom, in the front of the fraction symbol, or in the top, wherever we want it to go. Now I have to take the square root, and my answer is going to be plus or minus. I need an I for that. I cannot take the square root of 3, so I have to just leave it as radical 3, and the square root of 25 I can do as 5. So the answer to that is going to be plus or minus I radical 3 over 5. Again, when I have a square root of a negative, that's the I. Cannot do the square root of 3, so it stays, but I can do the square root of 25, which is 5. You can do that because it's just a fraction. All right. I actually want to come down here and do number 7, and then I'm going to let you guys go back and think about number 6. All right, how do I do number 7? I have to FOIL it all out, right? So I'm going to have to do the first times the first is 8. The outers, and I can't do the outers and inners at once because they're going to be different terms. So I'm going to have not like terms. Negative 12i cubed. On the inners, I'm going to get plus 4i to the 6th. And the last times the last, I'm going to have negative 6i to what power? 9th. Good. We're multiplying and the bases are alike. Add the exponents. Remember how I said our answers have to be in a plus bi form? So the only exponent I can have on the I is a 1. I got a cubed, I got a 6th, and I got a 9th. Well, I'm going to have to do some work here. Do you guys remember what I to the third was? Negative I. So now I'm going to have 8 minus 12 times negative I, that's multiplication there, plus 4, and then what's I to the 6th going to be the same as? Okay, let's go back. I just want to show you how you can do this if you know the pattern. Here's the pattern. So if I want to know I to the 6th, I to the 1st, 2nd, 3rd, 4th, 5th, 6th. So it's negative 1. And then what about I to the 9th? That's going to just be I, isn't it? Because I to the 9th is I to the 8th times I to the 1st. This is a multiple of 4, so it's 1 times I, which is I. Okay, so now we're going to have 8 plus 12i minus 4 minus 6i. So what's our real part going to be? 4. And what's our imaginary part going to be? 6. 6i. So this would just be an imaginary number. It's not a pure imaginary. That's it. Yes?
Could you simplify, like, the exponent, like I exponents before FOIL?
Very good. I was hoping that somebody would mention that. She's saying, why didn't we just simplify this at the beginning? Then we wouldn't have had to gone through all that at the end. That's a great way to approach the problem. So at the beginning, simplify those two and then go. And you'll get the same answer. Okay? All right, I want you to think about number 6 now. I want a function that has two real zeros at -2 and 2. And then I want a function, and you can sketch these or you can write the equations, and I want it to have imaginary zeros of -2 and -2i and +2i. Can you come up with those functions? Try it. Anybody know either one of these two? You can even just take a guess if you want. I want to have zeros of, first of all, -2 and +2. Can you think of a function that would give me that? Yeah.
X squared minus 3.
I don't think. If I solved x squared minus 3, if I set that equal to 0 and solve it, I'm going to get plus or minus radical 3 as my solution. And I want to get -2 and +2 as my solution. Lily? Okay, if I had x equals 0, that's going to give me actually infinitely many, well, x equals 0 would look like this. So that's not going to work. That would just be a vertical line. Yeah, what do you think, Alex? So you want it to be x minus 2 times x plus 2. Okay, so then if I set that equal to 0, then I would have 2 and -2 as my solutions. That works, doesn't it? So what is that equation if we multiplied it out? X squared, and what else? Minus 4. Okay, would that make sense if I solve this? X squared minus 4 equals 0. X squared is 4. Take the square roots. Would I get 2 and -2? Plus or minus 2? Okay, that's one of them. Good. 1, 2, 3, 4. That would be the way that would look, because those would be our x-intercepts. Anybody think they know this one now? I think you guys can do this. What do you think, Blake?
This is my guess, I guess. Is it just x plus 2i times x minus 2i?
Okay, I'll go with that. Now, I don't think you'd ever see it written that way, though. So let's multiply it out. X times x is x squared. The outers give me negative 2ix. The inners give me positive 2ix. Last times last gives me negative 4i squared. Okay, I like it. So now I've got x squared. What's negative 2ix plus 2ix? What's going to happen with those two? Cancel out. And what is negative 4i squared the same as? Plus 4. Would that work if I were, oops, I'm going to call that G. If I set that equal to 0, would I get plus or minus 2i as the solutions? Yeah. So that's going to be this graph that's been shifted up 4 units, right? So it looked like that. Remember back at the beginning when we solved this problem and we got plus or minus 3i for x squared plus 9? Okay, what if I want plus or minus 4i to be the solutions? What would be the equation? X squared plus 16, yeah. Okay, now it's going to seem real easy next time you see it. Plus or minus 5i? What is it? Right? What if I want plus or minus 6? Plus or minus 6, not plus or minus 6i, just plus or minus 6. G equals, or y equals x squared minus 36, yeah. Okay, guys, very good. Let's stop there.